Hello everybody, John Manning here, Technical Service Manager for Watson Boman Acme, BASF Corporation. We're out in St. Petersburg, Florida today. We're going to be installing some expansion joints with our new next generation system and WaboCrete header. We're pretty excited out here working with the contractor. This is going to be a great pilot installation, and we're hoping that you'll find the benefits and features of this system very beneficial for your corporation. Okay, so the first thing I like to do when I come out to a job site, I like to sit down with the contractor and all the employees out there, and the first thing we want to talk about is obviously what we're dealing with, what chemicals we're dealing with, what product we're dealing with, and also the safety features and the proper PPE that should be used out on the job site. After we review that and everybody's comfortable with that, what I like to do is I like to walk the job site, the length of the expansion joint. In this particular case, we're working on a ramp condition. So it's not a unique case, but it's a little bit of a challenge to it, right? So this particular challenge for this expansion joint is we're working on a slope condition coming down, right? And then we also have two upturns at each curb. So how we're going to address this today is we're going to pour our first pour is going to be right down here for the expansion joint first. We're going to let that material sit. Then we're going to come back and we're going to put some formwork in place right here and on that side down there as well. And what we're going to do is we're going to pour that afterwards. And that'll allow us to have a nice, neat, monolithic fit and look to the system. If you notice also is we like to protect our work site. Right? It's really important to make sure that we're protecting our work site. When you're working with chemicals, it's important to put down, I like to use roofing paper, but you could use plastic if you want, or whatever the case may be. You could use wood, plywood, but roofing paper is relatively inexpensive, goes a long way. You can cut it in half, and it's already got a nice straight edge on the side of it for you to work off of and tape off of. So we usually typically go out of half the roll on this side, half the roll on that side, and then if you notice over here, we'll set up our mixing station. Our mixing station is always located right by our area where we're working. Today down here in St. Petersburg, it's almost 90 degrees Fahrenheit today, right? So this is really going to be a more challenging installation from the heat standpoint. Once you start getting into the 90s and you're mixing chemicals, your working time dramatically diminishes, dramatically. So we want to make sure that we're all set up. Our whole job site's taped down. Our working station's all set up and ready to go. We checked the drill, made sure that's working. We have the proper drill for this particular job. We have the proper mixing paddle for this particular job. And we also have the proper trowels. Once we go over all that, I want to make sure also that our concrete deck is properly cleaned to the proper profiling substrate. So that would be a CSP profile 2 to 3. That's typically achieved by either abrasive blasting or sandblasting, but in many cases, you're not allowed to sandblast or abrasive blast anymore. So the next acceptable method for prepping the substrate to a CSP 2 or 3 profile is by grinding. Grinding can be achieved with a 4-inch grinder or larger, depending on the size of the blockout you're working on, with either a Zec wheel, which is an abrasive wheel, or a diamond cup wheel. So it just takes a little practice, and once you have a technique down, you just have to keep the grinder going and not sitting in one area digging into the substrate. It's very important that as you're grinding down the length of the joint on this concrete deck right here in our blockout, you want to keep that grinder going back and forth because you don't want to chew into the concrete. Right? Another thing that we're going to look for is to make sure that we have our proper blockout dimensions. When I talk about the blockout again, I'm talking about this area right in here. We're looking for a minimum 3.5 inches wide on each side and a 3/4 inch depth on both sides. That's the proper blockout dimensions you need for this type of system. We're working with the next generation ME expansion joint with the elastomeric WaboCrete header. We also want to take a look at our joint opening. Our joint opening is the actual opening in the deck where all the the thermal movement's going to take place during the course of the year. We want to make sure that looks relatively clean cut down. We don't want a snake-like joint opening. We want a nice square joint opening with a pretty even dimension all the way down, give or take a 1/4 inch or so. The unique thing we had about this particular installation was we have a 2-inch joint opening at about 90 degrees Fahrenheit. Our old system, the old ME 300, would be a little bit of a challenge to install and compress into a 2-inch opening. And also, we were told that the joint opening is going to exceed 3 inches. So we really couldn't go to a larger seal, 400, and the 300 really wasn't going to meet the movement criteria to 3.5 inches. So what we decided to do is go out and use our next generation ME system. We're using our ME 225 out here right now, next gen. The nice thing about that is the new design and criteria of that is it allows us to go down to the minimum movement out here of 1 inch and also to exceed up to 3.5 inches. So that's going to be really nice to meet the movement criteria. But the best thing about this particular seal and redesign of the system is we're not going to really struggle real hard trying to compress this material into the 2-inch opening, right? It's going to collapse and fold and drop in there relatively easy and quick, half the time it would compared to our old system. Again, what we want to review is to make sure that the blackout dimensions fall within our requirements. The minimum we're looking at is 3.5 inches wide on each side, 3/4 inch depth on each side. And it's really critical that we make sure that we get those minimum requirements. They can be a little bit larger wider, but we really want to try to maintain that 3/4 depth because that's really the critical depth that we need for the seal design, so the material doesn't flow over the top of it or out of the blackout. And when I talk about some of the features of the next gen seal, I've got a smaller piece right here. This is our next gen ME 225, and we want to make, when I was talking about some of the features, but when you look at the concrete, we want to make sure that the base of this blackout is smooth and flat with a nice 90-degree cut right here on both sides. And why that's important is because as that seal's installed and that flap sitting on that base, it needs a structural sound base for the header to sit on. If you have spalling there taking place, or you have a lot of big air pockets, they really should be fixed and addressed ahead of time. Otherwise, what can happen over time is as the live loads go over that area, you can get some flexing in the header, and it's not going to be fully supported because you've got a void there, and you could get some cracking. So going back to the features of the system, what we did is we've increased the size of our bulkhead right here. So this bulkhead comes out almost 3/4 of an inch now. So when it's installed, if there is a little rounded area right there, or if there is a little spall right here, our header material is sitting back now, okay? It's not sitting right on the joint opening edge anymore, like our old system and like our competitor system. We want that header to sit back in case, for whatever reason, there's a weak point here or something shears at this point, because we all know that this is the weakest part of the concrete right here. So one way to try to avoid that is push that header material back a little bit, that it's not sitting right on that edge anymore. That's a great feature and benefit of the new system. The other nice feature of it as well is the new design of it, right? It collapses very easy from an installation standpoint. You'll be able to install this in half the time as our older system. And typically, we're just going to go push it down and boom. If we were using our older system, it would be much more difficult to compress that down and insert that in. So you notice, just to revisit some of the key points, new bulkhead design, the new web design to make it easier to install, and also the WaboCrete itself, the elastomeric header itself, is physically sitting back now from the edge to alleviate any potential future spalling that may take place at those particular weak points. So you notice what we have here is we have our new next gen seal sitting by the blackout and the joint opening. Because it's Florida and it's really hot today, this thermoplastic material is heating up very quickly. So it's making it very easy to work with as well. If you typically were working in a different geographic zone, let's say it was 50 degrees up in the Northeast, my recommendation would have the seal rolled out down the joint, cut it to length, cut it to the length of your joint you're working on, roll it out, and let it sit out in the sun and relax. Because the thermoplastic properties, as it's colder, make it that changes the durometer of the material a little bit. So the hotter it is, the more pliable it is. The colder it is, a little bit tougher to work with. Because what happens is a lot of times is the material, as it's sitting on a pallet or during shipping, is packaged, and some of the flaps might be kinked. So this helps release the kinks in the flap of the seal, so it'll sit flat inside the joint opening. So since it's so hot here and this has been sitting out here for hours, we're really not going to see that much of an issue today with our ME system. All right, so after you install your seal, you can see that was an extremely easy install. 2 people did that in just a couple minutes. And we have two situations here that we want to address, right, that we're looking at right now. And the first one is we've got our upturn detail. What we didn't want to do is we didn't want to cut our seal. So since this is a nice soft 45 going up, we find no need in cutting the seal, making this shape. But what happens is you might get a little of the flap pushing out, right? So we're just going to cut a little pie piece out so it sits nice at that location. If we find that doesn't relax it at that particular upturn, we could always take a Tapcon, drill a part of the wing into the concrete just to hold it down on the upturn. As we walk down the length of the joint inspecting our install, we just want to make sure that our flaps are lying flat on the base of our block out. So again, sometimes what happens is you'll get a little bit of a wave in the flaps, and this happens for numerous reasons. Sometimes it happens because of the joint opening dimension. Sometimes it happens because it was sitting on a pallet for so long. Sometimes it's a little bit tighter in one area than it is in another area because the joint opening's not uniform. And it's a real simple fix. You either come with a razor knife or a pair of snips, and what you want to do is just do a little small pie cut. Don't want to cut anything more than a pie out of it, because we want to keep that piece there, right, to hold the WaboCrete in. And it only takes a couple minutes to really take a look and spend the extra 2 minutes taking a look at making sure everything's done properly. So again, this is a little bit of a unique situation. We're on a ramp again, and we have a 45 going up the wall right here. And we didn't really want to cut the seal, right? Anytime you can avoid cutting the seal, it's always a better decision. So we're just going to roll the seal up that 45 degree. What happens though is the flaps are sitting a little bit higher than what we want at this particular location. So what we recommend is we take a stainless steel Tapcon, and we're going to anchor it into the flap itself to draw that flap down and hold it in place during our part of the pour. Okay, so our next step is, after we installed the seal, we've got everything looks good, we're happy with the way the joint's laying. As every skilled tradesman knows, you want to protect your work area. So we're going to be pouring an elastomeric header on top of this. So what we want to do is we want to make sure that we're protecting this as we pour our material. If you don't protect the top of the surface, it makes for a very difficult install, and chances are you're going to over pour and get material inside the webbing. That's very difficult to clean. It's easy to avoid. It's just by simply putting duct tape from edge of bulkhead to edge of bulkhead all the way down the length of the joint. As we protected our area on the outside, we also want to make sure we're protecting the top of the seal. So our next step for our application is we want to put our bonding agent down. So the big misconception is it's really as a primer, but we're really not putting it down as a primer. We're really putting it down as a moisture barrier on concrete. WaboCrete is a urethane-based material, so we just want to make sure that there's no moisture content coming up through the deck during the initial curing process of the elastomeric header, the WaboCrete. The bonding agent itself comes 1-to-1 ratio, part A and a part B. It's 100% solids epoxy. What you need to remember is that you need to pre-mix the part B of the bonding agent before mixing it with the part A. The other thing you can do with the bonding agent is you can, if needed, mix partial units. You can mix half at a time, save it, and then mix the other half for another joint line. You can't do that with the WaboCrete, but you can do that with the bonding agent because it is a 1-to-1 ratio. What we're doing is we're opening up the part A and the part B, working on our protected work area. We have a half unit in this one because we used half on another joint line earlier today, but we still want to make sure that we pre-mix that part B. If you look at the particular drill we're using and the paddle that we're using, I like this particular style paddle because it can fit right inside the can and mix it real nice. The thing you want to keep in mind is you want to set this on a lower torque, lower speed, so you don't start throwing material all over the deck. So right now what we're doing is we're adding our pre-mixed part B to a clean container. We're going to make sure that we empty it out, make sure there's no lumps in it, it's nice and smooth. And then we're going to add the remainder of our part A. Go ahead. Again, start mixing really slow because you don't want to throw this all over the deck. You just want to mix this for about 2 minutes, minute and a half to 2 minutes, until it's mixed really well and there's no more clear spots in the material. Make sure somebody's holding the container so you minimize the risk of the material spilling. If somebody's holding it, then you can increase your speed once you have it under control. So we've got our epoxy mixed. The key now, especially in a hot day like today in the 80s and the 90s, you want to make sure you get it out of your container and get it into the blockout and put it down a thin layer. What we're trying to achieve here is just to make the concrete only, not the rubber or the seal, the concrete only on the horizontal and the vertical. We want to make sure we prime that. If you put it out on a thin layer, your working time increases dramatically. If you leave it mixed in a bucket, the exothermic reaction of the material kicks a lot faster. On a 90-degree day like today, we probably have about a 30-minute working time, which is more than enough for us to put this down. So, because this is only about a 25-foot joint, we're going to put it all the way down from end to end, and at that point, we're going to start placing WaboCrete. So go ahead, and one way you can put it down is to pour a ribbon. So what you're trying to avoid is ponding and puddling the material. So what you notice what we're doing here is if you do over pour a little bit, all you want to do is take your brush, push the material down with your brush. Push the material down with your brush, right? Drag the material down. See, you're going to make sure you want to get the vertical face and underneath the flap, you're lifting your flap, making sure you're priming underneath your flap and up your vertical base. Again, try to avoid pounding and puddling the material. If you do over pour, just push it down with your brush and work down the length of the joint. The other way you want to do it, if you find that it gets a little messy on you doing it that way, what you can do is just have your bucket right by your side. If it's a small run, you can get away with leaving it in the container, dipping your brush, and applying it as you move down. What you want to make sure is that if you were working on a longer joint, you only want to put down enough of the bonding agent that you're going to put header down on that day. You don't want the bonding agent to cure out on you. If the bonding agent does cure out on you, it could turn into like a sheet of glass, making it hard and difficult to bond to. So you would need to grind the dried primer off at that point. We don't want to wait. There's no downtime once this is applied. we want to pour wet on wet. So basically that means we want the bonding agent still wet and tacky as we're placing our elastomeric header WaboCrete down. So now we're getting ready to pour our elastomeric header. 3-component system. We have a part A, a part B, and the C is the aggregate. All you really need is one clean 5-gallon bucket to start. So what we want to do at the very minimum from a PPE standpoint is make sure we have our dust mask, gloves on, and that we have our safety glasses on. All right. At the very minimum, a dust mask of this type should work. Not that bad to work with, but we just want to be safe, right? So this is a urethane-based product. Pretty easy on you. You don't have to really worry about too much about it. We're working outside. The wind's blowing. It's a nice day, so it's not going to be too much of an issue. But we still want to make sure that we're taking proper precautions out here. Now, what we have here, again, because of our slope condition, we have a bag also 90 grams of our non-flow additive. What we're going to do here is you can add up to 1 full bag per unit or per mix. 1 unit goes about 0.6 cubic feet yield. This will not change any of the chemistry from a tensile or compressive strength point, but what it does is if you're working on a slope or a crown condition, it allows you excuse me, to thicken up the material because this is a self-leveling material on its own. So the first thing we want to do is we want to make sure we have the proper tools and equipment and we're ready to go. We're on a nice work area. Everything's protected. We have our nice heavy-duty drill. We have the right proper paddle. This paddle works best, I found. It's a grout paddle. You can pretty much find this in any Home Depot in the country in the grout and paddle section of a Home Depot. If you use this type paddle, it'll work, but what you're going to find out is as it's spinning in the bucket, it's going to throw the material all over the place, and it doesn't mix it as well. This one's much better to mix with. Usually what I do is at my mixing station, if I'm mixing several 7, 8, 9, or 10 units at a time, I line them up in front of each other, making sure that I'm mixing both the A and the B, and I don't forget one of the components during the mix. It can happen, and it has happened, so it's important. I find that if you set it up this way, you have less likelihood of forgetting one of the A's or B's going into the mix. Now, typically what I'll do is pre-mix the part B's, but because we're on a slope condition right here today, the material is going to run all over the place out of the part B can. So what we're going to do is we're going to pour the part B into the bucket, and we're going to scrape it real good with the trowel. Okay, so we've added the part B. You notice our mixing man's all ready, right? He's got his drill set up, checked it, he made sure it's working, everything's working properly. He's got his paddle already in the bucket with the part B. Once we start mixing, you don't stop, especially on a hot day like this with the exothermic material and with the heat of the ambient temperature and of the substrate. So we're going to open up our part A. Part A does not require pre-mixing. We're going to empty that into the clean 5-gallon container with the part B. We're going to pre-mix the part A and the part B for about 25 seconds. Now we're going to add our non-flow additive. We're going to start off with about a half a bag or about 45 grams of the non-flow. We're going to make adjustments all the way up to a full bag if we need to on the next mix, but we're going to stop. We're going to start with a half a bag and see how that works for us. Once you mix the part A and part B, immediately follow up with the parts C aggregate. You should be able to get this out of the bucket in about 40-45 seconds. You're going to keep mixing for about 2 minutes total mixing time until there's no more dry pockets in the material. Okay, pour it out, move it, pour it out, move it, pour it out, move it. What we want to try to do is as we're emptying the contents out of the bucket, we want to make sure that we're kind of moving and walking down the joint line, pushing and spreading the material, as we go down. You can see that it is a thicker consistency with the non-flow additive added to it, and really that's what we want for this type of slope condition on this deck. Otherwise we'd have to go back and rework it and rework it and rework it because it's a self-leveling based material. But the key is to push the material down and make sure we get all the material out of the bucket. As you're finishing the material, you want to make sure that you're using your margin trowel. Make sure you're using your margin trowel, working off a grade in the seal as your working point, going down. You can use a solvent. You can use a solvent on here. I would suggest toluene or xylene. No alcohol-based solvent is good for urethane-based materials. So stick with xylene or toluene. It's easier if you clean your trowels as you're working down the joint line. Okay, the material's been put down for a couple minutes. It's an extremely hot day out today. We have a very quick reaction time. We want to make sure, as it's still tacky, that we broadcast our specialty clean and washed aggregate on top, our angular aggregate on top of this. You want to broadcast to excess. Go ahead. You want to start broadcasting to excess, just like you were doing a deck coating. It's still, you got to get on it quick, especially on a hot day, to make sure that it bonds and sticks to the elastomeric concrete. Again, being a hot day, we want to make sure that we get our tape up and our tar paper up as fast as possible. Like, we should have a guy right behind the broadcaster start rolling up and cleaning up as we're working down the joint line. If you wait too long, it'll be very difficult to remove all the duct tape off the concrete and off the seal itself. As you're rolling up the tar paper and the duct tape, take your trowel and make sure that this edge is smooth with the deck.
Gotta get your tape. This joint installation was absolutely awesome. The workability was phenomenal. The cleanup was next to nothing. I mean, the materials themselves mixed together perfectly. The timing was not too much to deal with for me and the rest of the crew. I cannot express how happy I am with the final product here. I mean, it's gonna match very well with the BASF product that we're going to be laying over top of this. And I really can't say that we had any problems at all today.
Okay, we just finished putting in the joint here in Casa del Mar 1. I tell you what, it was an amazing experience because it was so easy to put in. It really went well. It really looks good. We're getting ready to put a BASF traffic coating over the top, which should match in with it really nice. And we're very pleased with the job.